No, it integrates this.
I understand that.
So then what you do with this table?
It's familiar.
So
That's tabular method. I know tabular method.
multiply x squared times this, and that term's gonna be. So.
Tabular method?
It's more than.
I think let's do like shoot it one time. If I do not allow to put this in your spot.
But it only works when certain cases. This has to terminate to 0. And this has to always, this can't terminate. It has to like one. Like EDX will always be EDX.
Okay, your time is up. Okay. Practice quiz number 2. You go with that one. Okay. So you have to know how to are going to solve the differential equation or sort that we talk about it, homogeneous, linear, linear equations. Okay, so the first part is going to be homogeneous equation with a constant coefficient. So you have to form, the characteristic equation and get the solution. So we give you a couple of them. Okay, it may be of a second order or higher. So you got to be prepared. Okay, so this is the practice quiz that I'm going to do for you. Okay, so the first group are going to be this one. Find the general solution of each equation. All homogeneous equation with constant coefficient. So for each one of them, we are going to get the characteristic and we go for it. So that's it. Let me take care of this group first. So that is going to be practice quiz. Okay, that's it. Number 2. I'm going to post this notes later. So number 1, solve each equation. Okay, solve each equation. They are kind of straightforward, but you may have difficulty with taking when the order is higher. We're going to explain it, how to take care of those. Okay, part 1. Part 1, the equation is y double prime minus 2y prime plus 10y equal to this. Okay, it's straightforward one. Constant coefficient, and you go for the characteristic equation. Okay, what's the characteristic equation for this one? Very good. That's it. We solve it. Factoring is possible, so check to see if it's possible. You need to find 2 numbers with the product of 10 and a difference of 2, which is not possible. Okay, so you go with the quadratic formula. You get it? So it's going to be -2, which is going to be 2 plus or minus 2 squared. Okay, minus 4ac divided by 2a, 2 times 1. Inside that radical is going to be 2 plus or minus. You get 4 minus 40, which is a nice number. So that gives you -36, which is going to be 6i. Okay, so r is going to be equal to the 2 plus or minus 6i. You break it into the complex form because you need those coefficients. So that gives you 1 plus or minus 3i. So the solutions are complex. So we take one of them and you know the solution. So you have 1 plus 3i. So this is your alpha plus beta I. So we get an alpha equal to 1 and the beta equal to 3. You know that the solution would be e to the alpha x cosine of the beta x, e to the alpha x sine of the beta x. And then we're done. Okay, so y is equal to C1 e to the alpha is 1 e to the x cosine of the 3x plus C2 e to the x sine of the 3x. And you're done. Okay, we do the same thing after your quiz. We do it for the so-called Euler equations. Any question? So that's case 1. We give you 3. You see, it's going to be complex, repeated, and distinct, and you get 1 with a higher, okay, higher order, higher than the second. Okay, that's first one. Checking the second one. Part B, y double prime minus 6y prime plus 9y equal to 0. Again, straightforward equation. Get the characteristic equation. What's the characteristic equation for this one?
R squared minus
9. You factor it. R no, I minus 3 times R minus 3, which is the square. Okay, the product of positive 9. So it's a repeated solution.
We have to raise it to the power of x.
That's it. Yeah, you multiply by x. So in this case, if we have a repeated solution, R equal to 3 is a repeated solution. Okay, you just go ahead and do it. Your first solution is going to be ordinary one, e to the Rx, which is e to the 3x. Since it's a repeated one, the second one would be x e to the 3x. So y would be, the first one is e to the Rx, which is e to the 3x. Second one, we multiply by x, e to the 3x. And then we're done. Okay, if it's going to be higher order, and that will be repeated 3 times, it's going to be x e to the 3x, x squared e to the 3x. Okay, so it depends. But you have to give 2 solutions, you need 2 solutions. One of them will be repeated. Okay, so it's again case 2. Any question? So we need the one with the distinct. That should be part C. Part C is y double prime minus 2y prime minus 3y equal to 0. Again, straightforward. Characteristic equation would be what? Would be r squared minus 2r minus 3 equal to 0. Factoring. Give us the numbers for factoring. R minus, yes, r minus 3 times r plus 1. So we have 2 solutions. Okay, you can call it R1 equal to 3. It doesn't matter which one I know. You call it R1 and R2 equal to the negative 1. So 2 distinct solutions. Each R would give e to the Rx, and then the combination you're finding answer. So y equal to the C1. C1 e to the 3x plus C2 e to the negative x. Finding answer. Okay. So these are a second order. Yes.
I thought this was the YC, not just the Y.
No, this equation is homogeneous.
Oh, that's well.
So it's all y. And it's going to be non-homogeneous. This would be YC. There is no YB. Okay. So that's the second order. Now a couple of higher order. So we can separate. Okay, so that would be part B. You may use the grouping method, or in worst scenario, you may use synthetic method to do it. Also, you got to be prepared for all of them. Okay, so start with the part D. Part D is y tiers. Okay, the third. 3y double prime minus 4y prime minus 12y equal to this. Okay, so the equation is a question of a third order. Okay, the main method for this in future is going to be Laplace transform, but in this case, we can do it. Yes,
Factor by grouping.
we have to write the equation first.
Yeah, that characteristic,
Yes, what's the equation?
R cubed plus 3R squared minus 4R. Minus 12.
Minus 2, okay? Since it's a 4 term, you check factoring by grouping first.
R squared.
Okay, so you factor these two, you take out the 3R squared. So the leftover would be R plus 3. We want to make R plus 3 over here again. So that's negative 4, so you pull out the negative 4. Negative 4 out. So that gives you R plus 3 equal to 0. Now the common factor is R plus 3. You pull it out. R plus 3 times R squared minus 4. R squared minus 4, we can handle it, but you can factor it as well. It's going to be R plus 3, R minus 2, R plus 2, equal to this. 3 distinct factors. Okay, so you may call them R1 equal to the negative 3, R2 is equal to 2, R3 equal to the negative 2. The same thing. Each R would give e to the Rx. Okay. What's question? Any question? Okay. So we go for it. Y would be equal to the first one, C1 e to the negative 3x. It's not a repeated solution, you're done. If it's going to be repeated solution, you have to take care of. Plus the second one, C2 e to the 2x. Again, it's not a repeated solution. So we're done. Plus C3 e to the negative 2x. And this is not a repeated solution. So this is going to be the final answer. Okay, so whatever we did for the second order, we can do it for the third, or the fourth, the fifth. That's a nice case. So the equation was nicely factorable. Any question? Let's get another one. Part E. Just to make sure that we are able to factor it. So this is the equation of the fourth order. So y to the fourth, this is the fourth derivative. Okay, minus y equal to the 0. Okay, you know that. When you get, it's going to be 3 out of 3, 4, 5. This is the way we write it down. Okay. So what's the characteristic equation for this one?
4 minus 1.
R to the 4 minus 1 equal to this. How are we going to factor this one? Okay, so it's going to be R squared minus 1 times R squared plus 1 equal to this. You can handle the other two, okay? You know, you can write the first one at least into the R1, R minus 1, R plus 1, R squared plus 1, you keep it, then you change it to the complex number. So we get two solutions from the first two. So we're going to have the R1 equal to 1, R2 equal to the negative 1. Okay, the other one you have to work on it. It's R squared plus 1 equal to the 0. You move the 1 to the other side, that gives you negative 1. You change the negative 1 to the I squared, then you have two solutions. Okay, so R would be positive negative 1. Okay, remember the complex solutions are acceptable. So you cannot say that there is no solution. All the equations would have solutions. So we get two complex here and the two real. Okay, so pick one of these. Okay, R equal to the I to identify the alpha and beta. So it's going to be R to the I. You know that this is like 0 plus I. So alpha is 0 and the beta is 1 for the complex units. So 4 solutions. Y equal to C1 R1 is 1, e to the x. That's the first one. Plus C2, e to the R2 is a negative 1, negative x. Then the complex, plus C3, alpha is 0, is e to the 0. You can ignore it. Or you can write it down and simplify it, okay? It's going to be e to the 0, cosine of the, okay, cosine beta is 1, cosine x, plus C4, e to the 0, sine of x. But e to the 0 is 1. So we have to rewrite it. C1 e to the x, C2 e to the negative x, C3 cosine x, and the C4 sine x. So this is going to be the final answer. Okay, you did have the equation of the fourth degree, fourth order, so you should have 4 solutions. And we have all the solutions. Yes, that's good.
How do you determine your alpha zero and beta zero?
R is I. And R is I. There is no zero, there is no real part. So you write it on a 0 plus I. So alpha is the 0 part of the complex number, which is 0.
So if we,
Beta is the complex part, which is 1.
so if we had, for example, I is always with one I, basically, it's always.
Yeah, it's a 0 plus 1 I. You can think about it, 0 plus. That's why I write it down 0 plus I. Okay, there is no real part. So alpha is 0. Any question? So that's, give you an idea of when it's going to be higher order. Now we need to give you one more. This is the one that you got to be careful how we're going to factor it. Okay, so that was DE and part F. Part F is the equation of the fourth order. Okay, part F. The equation is this one. Y to the fourth power, fourth order. It's going to be Y tiers minus 7 y double prime minus y prime plus 6y equal to the 0. So it's a fourth order. You have to get 4 solutions for this one. Okay, change it to the characteristics for first to see what's going to be the result of the equation. What is the characteristic equation for this one?
R equals 1. Can you put R?
No. What is the characteristic equation first?
R to the 4.
That's it. R to the fourth, R to the third, minus 7R squared, minus R, plus 6, equal to this. It's in fact 6R to the 0, but we write it down 6. You see, you start with the 4, 4, 3, 2, 1, 0. So the last one is 4R to the 0. So R to the 0 is 1.
If we use synthetic division, if we have all the coefficients, it would give us the answer. That means.
Yeah, you must use for synthetic division for this one. It doesn't matter whether you get that one or not. But we check to see if you get the 1. You see, check the sum of the coefficient. What's the sum of the coefficient?
Yeah.
0. You're lucky. Okay, so we get one of them. It doesn't matter. We can find it, even if it's not going to be given to you. So it's going to be 1 plus 1 minus 7 minus 1. If you get the 0, we accept it. So this is 0. Since it's 0, one of the solutions is 1. So R, R1 equal to 1 is a solution. Now that will help you to use the syntactic method to reduce the power, reduce the equation, 1 dot. It's the fourth equation. We change it to the equation, the cubic equation. Remember we talked about the other night how we're going to do it. This is going to be 1. You list the coefficient of that polynomial that we have. The coefficient 1, 1, negative 7, negative 1. Okay, negative 1 and 6. So these are the coefficients that we have. We bring this one down, and we get this line here. And what we're going to do is, we are going to multiply the 1 by any number in this line, and you put it on the top. It's like that long division that we do. So the first part would be 1 times 1 is 1. Then you add them together. When you add them together, that gives you 2. Then you repeat it again. 1 times 2 would be 2. So that gives you negative 5. You repeat it again. 1 times negative 5 would be negative 5. That gives you negative 6. You repeat it again. Negative 6. You must get 0. Because you already predict.
Oh, you have them.
Okay. Now, this is going to be when you divide, this is going to be the, okay, we call it the shrinking polynomial. You start with the r to the 4th. So your quotient would be 1 dot. So this would be what? This would be 1 times r to the 3rd, if you like. I write it down. 1 r cubed. It's going to be, second one is going to be 2r squared minus 5r minus 6. This is going to be result of the equation. So we have to take care of this one now. Okay, so we have r cubed plus 2r squared minus 5r minus 6 equal to this. Okay, we shrink it. You know, we reduce it by 1 part. Okay, any question? So this is going to be result equation. Now you have to continue. You have to find one solution for this one to be able to do it. Okay, again, you add the sum of the coefficient. They may get the repeated one. So check it again. But it's not. Okay, then you have to guess what's going to be the other solution. You know that from, you have to school in public algebra. So the solutions are going to be what? If you get an integer solution, that solution must be divisor of the 6. So you list the divisor of the 6. 6 is divisible by what? Number
2, 3,
1, 2, 3. Plus or minus.
That's it. Yeah. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So these are the candidates. So you can use syntactic methods to find one of them again, or you can substitute. This one of them. You get this done. Okay? You already check the one, so we can check the given one. Okay? If you are lucky, you get it right. Yes, last question.
So the R cube, R squared, and then minus 5 are all equal in like descending order for the power.
That's it. It's polynomial. Yeah, yeah. You see, the way you started, what it is exactly the same. The fourth, the third, the second, they are okay. It's fine. Okay, so just check. Yes.
Can you explain the part where you said, what 6 is divisible by? Why was that?
It's called the part here.
That word
Okay,
here?
the part.
Right.
The car.
The part.
Dicker, thank you.
Range. Okay, we got it. The other name is rational region. Rational. Rational zero theory. You see, if an equation would have a rational solution, you know that there's going to be P and Q, so the coefficient is 1, you simplify it. You say that equation, that number must be a divisor of 6. If it's that way. So you check the divisor of 6, a couple of numbers. Then you have to find one. Okay, you can try syntactic methods to get it again. But that's not to give you some. Okay, quickly, you can check. Okay, for example, if you check the negative 1, you can check it here. You see, if you check the negative 1, that means negative 1. Negative 1 plus 2 plus 6. Okay, so it's not a negative 1. Because this could be cancelled out, and then you're not going to get it. So negative 1 is not true. So we can check the 2. Negative 2, 3, negative 3. Okay, so you can check a couple of them with there. Okay, so the possible solutions are the following. It may be positive negative 1, positive negative 2, positive negative 3, positive negative 6. So you have to find one of them. So for example, if you want to check the 2, just check the 2 with the syntactic. You see the coefficient of this polynomial are the following: 1, 2, negative 5, negative 6. Bring the 1 down. Which one? Positive negative 1, positive negative 2, positive negative 3, positive negative 6. 6 is divisible by 2, 3, 6. Okay, now we're checking two. 2 times 1 would be 2, that give you 4. 2 times 4 would be 8. So that give you 3. 2 times 3 would be 6. Oh, you're lucky, got it. So R equal to 2 is the second solution. Okay, yes,
-1.
would work?
-1.
Does work or not?
It works.
Okay, okay, no problem. So I save it true.
Do we need to find all of them, or is it?
Of course, you have to need to find. Yeah, suppose you missed the one. Because we have to get to do the new one. Okay, so this will tell us that R equal to 2 is one of the solution. Then the shrinking polynomial is what? That was cubed. So this is going to be a square. So what do you have? 1R squared plus 4R plus 3 equal to 0. And this equation is easy to solve now. You factor it. So this would be what? R plus 1 times R plus 3 equal to 0. So we get another solution, R equal to the -1, and we get another solution, R equal to the -3. So as you can see, all your solutions are going to be divisible by, okay, they are divisors of 6. So it depends. You may get the -1 first, then you go to the other one. So you need one of them. Then it's a 4th degree, you need 2. You need the first one to change it to the cube, and you need another one to change it to the square. So when we get a quadratic, you can factor it or you can use quadratic formula. So that would be, that would be the result. So list your 4 solutions. There are 4 distinct solutions, and then we are able to give you so what's going to be the solution? The solutions are, if you like, R1 equal to 1. It doesn't matter how you name it. R2 would be 2. R3 would be -1. And R4 would be -3. They are all distinct solutions. So what is the final answer? C1 e to the R is 1, x. C2 e to the 2x. C3 e to the -x. And C4 e to the -3x. So that would be the final answer. Yes. Descartes theorem. That's a theorem. That's a famous theorem. No, you see, the Descartes theorem will tell you this one. If you're given a polynomial, okay, in this case, it's very special one. The coefficient of the highest, let me bring it up. So this one. This is the one. If you begin a monic polynomial, monic means which coefficient is low. If you given a monic polynomial, if an integer is a rational number, it's going to be the solution of this equation. That's a rational number. Math divide 6. Okay, it doesn't mean that the other one is correct. If it is a solution, it must divide 6. So the integer solutions are going to be divided by 6. So you check to see 6 is divided by 1. Half of -1, half of -2, half of -3, half of -2. They are the can. It doesn't mean they are going to be.
Okay.
Then you have to test it. How to test it? You have two choices. You can substitute the number inside, it's equal to 0, or you can just, it doesn't matter. If you substitute, then you have to come back in synthetic method. Because you need the leftover. If you find, I find the first solution, 1. So I check the one with the synthetic method, or line division. In order to get the leftover, if you don't want to use synthetic method, you have to divide this one by R minus 1. Using line division. Okay? But in the line division, you need to shorten it. In the synthetic, you just, it's the same thing. You put the coefficient, and you use this method, you not get to 0. This is going to be the leftover. And you divide it to the left. You have to repeat it again. Again, it's a 6. So you need one more number, because all cube you cannot fraction this one. So that's why we check, we find out the other number is true. Then you continue with the true, you reduce it to the quadratic. Whatever equation can be solved. Okay, so that's one option for the, okay, that's why we give it this one. Because you may need it.
One more quick question. So you chose to find that the numbers that are given in the answer from afterwards.
Yeah, you see, you are done with the cube, you are done with the four, so we shouldn't get to the there, so you're not going to do it again.
Yeah.
You know this, so you have to check those numbers in the leftover.
Okay.
It's like dividing, you see, you pull out the factors one by one. R minus one out, the leftover cube. R minus two out, the leftover is 24 out. Okay, so that's going to be. Yes,
So if we didn't have -6 before the zero, let's say we had -7, -8. Would we find numbers that
Bad
are
luck.
divisible by 8?
bad luck, bad shit. If you get a -7, it means that number is not the solution. You leave it, you go to the next.
Before the zero.
Yeah,
If we have like
you are looking for the zero.
Yeah,
If
before,
you don't get the zero, okay, if you don't get, you go to the different.
like, if you had -6,
Okay,
before the zero, if we had -8,
you get it.
could we find numbers that are divisible by 8? In order to do this?
No,
division again?
No. You just think the algebra. If you get a -8, you put the -8, -8 and 6 is a -8. This means it's the wrong thing. You go to the next one. Because you wanted to make it 0, okay? This is the better. I knew that the 2 is one of the solutions, that's why I checked the 2 there. Okay, that's it. Yes.
That method only works if it's a third raised to the third power.
No, just have to vote for everything. Okay, that's one. That is 4 is better. No, you go to the 5, you go to that. We just wanted to remind you, you must know this, okay? Because there are some, you're not going to work always with the quadratic equation, okay? Suppose the face the same. Okay? So just review this one, make sure you are able, okay, to do it. Any questions? So we are done with the quadratic with the constant coefficient. Okay, so we give you a couple of them, it's going to be, repeated one complex is doing, but of course, we give you one of these, okay, higher order. If you want to know. And in future, we have another method to do that, it's very easy. Okay, that's why we wanted to know. Okay, so if you need anything about synthetic one, then you can, after the lecture come here, I explain more for you. So this is number 1. First question. Okay, ready for the second one? The second one is, you know that, these equations are homogeneous. Now how about none? Okay? How are we going to solve non-homogeneous? You know that, in order to solve the non-homogeneous one, this is the list, okay? That's the one. Okay, look at this. These are non-homogeneous. Because we get from the So are we going to do it? No. We're going to make it homogeneous set. Since we have a constant coefficient, as we did it before, we can solve it and get it. The solution is going to be called YC, complementary equation. Then you have to come back and find the YP. In order to get the YP, we introduce 2 different methods. The method of undetermined coefficient and the method of variation of problem. 2 different methods. In this case, you have to follow the instruction. You have to use undetermined coefficient. Remember, undetermined coefficient can be used only if you have 4 different types of functions, only. Exponential. There's a metric one and polynomial. Okay, these are going to be. So with the instruction that we talked about it before, okay, we are going to find the YP and we come back, YP plus YC is going to be the solution of your equation. You have to manage your debt. but this takes a little more time. And then you're, it can be done, okay? So we give you a couple of them. Remember, you have to solve it here. There is gonna be another one that you don't have to solve, but this is the one, okay? Let's do it one by one. So this is number 2. And again, we want to solve each equation. Okay, solve each equation. Okay, going for the part 1. Part 1, the equation is y double prime, 3y prime, minus 10y equal to 6e to the 4x. Okay, do the homogeneous one first. Step 1, make it 0 yourself and solve it. Okay, solution. So what we do is we solve this one first. Y double prime, 3y prime minus 10y equal to this. Because we are looking for the YC first. You see, we look for the YC first. Complementary equation means the one that you make it 0 here. And again, you know, characteristic equation would be r squared minus 3r minus 10. They are going to be all quadratic. Nothing to worry about for this group. Okay, and this is factorable.
Switch the sign up.
Oh, sorry. Okay, so what's going to be the term, the numbers? R plus 5 times R minus 2 equal to this. We get 2 solutions. Okay, you can call it this first one R1 and the second one to be, okay, 2. Doesn't matter which one are going to call R1 or R2. So we get the YC, C1 e to the negative 5x, C2 e to the 2x. So this is going to be step 1. Any question? So step 1, you make it 0 yourself. Okay, it's going to be homogeneous equation in this one. Now we have to find the YP. Okay, so what is YP? You check your function, R of x, remember the one to the other side. It's a 6e to the 4x. You see, we look at the coefficient of e to the 4x, and you make it into a polynomial. So the coefficient of e to the 4x is a constant. So it's a constant polynomial. So you introduce a constant polynomial with the unknown coefficient, which is A0 or A1, doesn't matter. You can call it A. Okay, so then this is it. So from this one, you realize that your YP would be, I go with the A1 e to the 4x. Okay, because I just change the coefficient. Then you check to see if there is any repeated duplicated term. You see if this term e to the 4x is here, then you have upgraded. You multiply by x. In this case, you don't need it because there is no duplicated term over here. So make sure you check it. So we check it for the duplicated term. We didn't get anything wrong. So this is going to be the candidate. Okay. Yes, that's good. Duplication means repeated, the same one. So you check to see if this is here. You compare them together. So these are e to the negative 5x, e to the 2x. This is e to the 4x. So they are not similar to that. That's a duplication. Okay. Okay. Now what to do? We have to find the a. In order to find the a, you have to substitute into the original equation. So to substitute, you need the, you need the derivative. So this is how we're going. So we want to find the a1. So this is it. We go with the function. The function is a1 e to the 4x differentiated. What's the derivative? That's it. Exponential function never change. That you have to multiply by u prime. Derivative of 4x is 4. So 4 a1 e to the 4x. That's y prime, y double prime, 16, another 4, 16, a1 e to the 4x. Okay, derivative of exponential function is exponential function times u prime. Go back, drop it into the equation. Okay, this is the equation, I rewrite it. So you know that what we are going to do. So drop it here. So y double prime is 16, 16 a1 e to the 4x minus 3y prime, 3 times y prime, 4.
Plus 3y prime.
Is it? Oh, I just change this all the time. Plus, yes, thank you. Okay, plus times 4a1 e to the 4x minus 10y, 10 a1 e to the 4x equal to 6 e to the 4x. Okay, that's it. So it would be end up with the 16 a1 e to the 4x. This would be 12 a1 e to the 4x, and this would be minus 10 a1 e to the 4x equal to the 6 e to the 4x. You can divide by e to the 4x. Okay, that's it. What's the leftover? So the leftover would be 16 a1 plus 12 a1 minus 10 a1 equal to the 6. Combine the like terms. So that we have positive 2, 18 a1. Okay, 18 a1 equal to the 6. So a1 would be 6 over 18, which is 1/3. So a1 is equal to the 1/3. So your yp would be, remember the yp, a1 is 1/3, it's going to be 1/3 of the e to the 4x. That's it. That's the yp and the yc. So the combination of these two are going to be the final answer. So y equal to the yc plus yp. We accept it, but if you want to see it, this is it. Y equal to the c1 e to the negative 5x plus c2 e to the 2x plus 1/3 e to the 4x. But if you write yc plus yp, we accept it. So that would be the fine. It's very typical problem of this section. Short, nice, okay. But the way they do it, they just put it so that you get a repetition. You get a duplicate terms. Yes.
After this one, would we need to plug in YC and YP or would it be okay?
No, if you like yc plus yp, we accept it
Okay.
right away. I just want to write it down because it's the first time,
Yeah.
so you see it. How it looks like. Okay, so that's that one. Any question? So that was nice. Okay, no duplication, nothing. So let's take another one. So that's a type 1 exponential type. Okay, let's take part B. Part B is kind of trigonometric one. You may get the repeated duplicated terms. Okay, part B, same numbers. Part B. The equation is y double prime plus 4y, y double prime plus 4y equal to 3 sin x. That's it. Again, you have to solve the homogeneous one first. So it's going to be y double prime plus 4y equal to the 0. What's characteristic equation for this one? R squared plus 4 equal to the 0. Not factorable, you move the 4 to the other side. Use complex numbers. So it's going to be -4. And the -4 would be like 4i squared. So R would be positive -2i. Complex solution. Pick one of them and alpha beta. Identify alpha beta. So R is going to be 2i. So it's like 0 plus 2i. So your alpha is 0. Your beta is 2. That's it.
So just to be sure, we only use beta if we have an I in their solution? If
Yeah,
it's
if
not-
it's complex number.
Yeah, okay,
If it's not complex, you don't need to.
okay.
Okay. So the solution for YC is equal to C1 e to the, you don't have to, but I just write it down again. Alpha 0, cosine of beta x, beta is 2x, plus C2 e to the 0, sine of the 2x. So the YC is C1 cosine of the 2x, okay, plus C2 sine of the 2x. So this is going to be your YC. If that was 3 sine of the 2x, that would be better, but it's not. Okay, so we need to find the YP. So R of x, again, it's a safe one, is a 3 sine. So the coefficient of the sine, again, is a constant number. So you need to bring a constant polynomial. But you know that for the sine, you have to bring a combination of a sine and a cosine at the same time, okay? So the suggestion for YP is going to be something like A1 sine x plus A2 cosine x. That's it. You check to see if there is going to be any similarity, duplication. It's not, because that's a cosine of 2x and the sine of 2x, but you have a sine and a cosine of x. If the given one was 3 sine of the 2x, then you have to multiply everything by x. So that would be the given thing. In this case, it's not. So very safe one. Okay, so the checking is completed if you like. So we go with the first, the given one. Now you have to go back, substitute, and get the, okay, get this A1 and the A2. Okay, so this is it. So the YP is A1 sine plus A2 cosine, differentiated. Lift up a sine cosine, so that gives us A1 cosine. You have a cosine negative sine, A2 sine. You have to do it again. Because Y double prime would be what? And derivative of cosine negative, so it's going to be negative A1 sine. And derivative of a sine cosine negative A2 cosine. Go back, substitute, and find the A1 and the A2. Okay, you're going to substitute the original equation. Y double prime plus 4y equal to the 3 sine. So substitute, y double prime is negative A1 sine x, okay, minus A2 cosine x, that's y double prime, plus 4y, 4 times A1 sine x, plus A2 cosine x, and this is equal to the 3 sine x. You have to multiply it, and you break it in 2 parts. The part with the sine and the cosine, and then use something like the one that we did for the polynomial. The coefficient of those monomials that we talked about. Okay, so first you have to multiply this one by 4. So that gives you negative A1 sine x minus A2 cosine x plus 4A1 sine, okay, plus 4A2 cosine, and this is equal to the negative 3 sine. Put the sine and the cosine together. You see, this is simplified if you can. You have a negative A1 sine, and this is going to be negative 4. So you simplify it. So that gives you 3A1 sine x. Okay, and for the cosine, you get the negative 1 and the 4, that give you 3 again, yes? It's going to be plus 3A2 cosine of x, and on the other side, we get 3 sine x. Okay, now as we did it for the polynomials, the coefficient of the sine here is 3A1, The coefficient of the sign on the other side is 3. So you let these two be equal to each other. So that give you 3a1 equal to 3. That's the first one. You do the same thing for the other one. You see, the coefficient is 3a2. There is no cosine here. Okay, you can think about it as the coefficient of cosine is 0. It's like 0. You see, like 3 sine x plus 0 cosine. Okay, so in this case, you get the 3a2 equal to 0. So from the first one, a1 would be 1. And from the second one, a2 would be 0. Okay, those coefficient that is like the polynomial that we did. Okay, and so we go back and we get the yp. Remember the yp was a1 sine plus a2 cosine. Now, so yes. What's question? Oh, okay, sorry. So we are going to substitute these into the yp. Okay, into the yp, so it would be a1 sine plus a2 is 0. Okay, plus 0 cosine. So which is going to be sine x. So the yp is simply sine x. Okay, so that's it. The general solution of the equation, of course, is yc plus yp, and then you're done. Okay, so we didn't get the duplication one, but you're going to get it in part C. Any question? So, you know, it's not a difficult operation, but be careful. So the good one is the next one. Any question? No, we already identified the yc and the yp on the top. You can write it if you like. But you have to tell us y equal to the yc plus yp. Unless you want to do something extra. Unless there is going to be initial condition, of course you have to form it and define it. Okay. Now let's do part C, which is different. Okay, let's see what's going to be different about this one. Part C. Y double prime. Sorry, y part C. Y double prime minus 2y prime. I'm sorry, this is the wrong one. Part C. I have to rewrite it. It's going to be y double prime plus 10y prime. Okay, plus 25y equal to the 14 e to the negative 5x. Let's see what is it, especially about this one. The coefficient are 10y prime, 25y. So make it into a homogeneous solution. So you have y double prime, 10y prime, 25y equal to the 0. Make it into the characteristic equation. What's characteristic equation for this one?
R squared.
R squared plus 10r plus 25. You factor it.
R plus 5.
R plus 5. R plus 5. You see, we get a repeated solution here. So R equal to the negative 5 is a repeated solution. Just for your information. Okay, repeated solution. Okay, so what's going to be YC? YC equal to, we get a C1 e to the R is a negative 5. So that gives e to negative 5x. It's going to be a first solution. But it's a repeated one. Since it's a repeated one, what's going to be the second one? C2x e to the negative 5. You see, that's something new about this one. Since it's a repeated solution, you should have two solutions. You know that we proved it already. You can use reduction of the or the formula to give it. But we know it and we use it. Okay, so C1 e to the negative 5x, C2x e to the negative 5x. That's a YC. Any question? Ready for the YP? Let's see what's going to be YP. YP. What is your Rx? You see R of x is 14 e to the negative 5x. It's a constant polynomial times e to the negative 5x. So we are going to introduce a constant polynomial. Okay, so your YP is going to be A1 e to the negative 5x. How do you check it to see if it's going to be a good one? Yeah, if you multiply by x, that give you x e to the negative x. Again, you have to repeat it. Okay, so the checking YP would be A1 x squared e to the negative 5x. If you miss it, you go back when you substitute, everything to the left of your equation would be 0. So all those parameters, you know, or A1 would be disappear. So if you happen this, that's it. You just go back and upgrade it. Any question? So we cannot use the x e to the x because it's already here. So the solution is A1 x squared e to the negative 5x. Okay, now we have to substitute in the original one, so we have to differentiate it carefully. Okay, so we go for it. YP is A1 x squared e to the negative 5x. Get the y prime. You have to use the product rule, remember. Derivative of the first one, derivative of x squared times the second first. So the derivative of the first one would be 2a1x times the second one e to the negative 5x. That's the derivative of the first times second. Now plus the second times first. Second is exponential. Exponential function never change. Your prime would be negative 5. So it's going to be minus 5 a1 x squared e to the negative 5. So that would be y prime. Okay, the derivative of the first times second, derivative of x squared 2x times second first, exponential function that give you negative 5 e2, okay, negative 5 a1 x squared e to the negative 5x. Okay, that's the y prime. Continue y double prime. So what's going to be y double prime? Carefully differentiate it, because you have to use the product rule for both of them. The first one, derivative of the first times second, that give you the derivative of x is 1, 2a1 e to the negative 5x. Derivative of the second e to the negative 5x. You get the negative 5 times 210 minus 10 a1 x e to the negative 5x. Okay, so I just apply the product rule to the first term, of course. Derivative of the first times second first. Any question? Now we have to do the second one, the same thing. Derivative of x squared is 2x, 2 times 5, 10. So that gives you minus 10 a1 x e to the negative 5x. Okay, plus the second times first, if you had another negative 5, negative 5 times negative 5 would be a positive 25 a1 x squared e to the negative 5x. Okay, so we just check to see if there is anything to simplify. You can simplify it. We can simplify these two. Okay, so the y that, so these two. So y double prime, yp double prime would be 2a1 e to the negative 5x minus 20 a1 x e to the negative 5x plus 25 a1 x squared e to the negative 5x. Okay. Now you have to go back and substitute everything into the non-homogeneous equation and get this coefficient A1. There's only one parameter, right? It takes time to find it. Okay, so there you are. I'm going to substitute here. So we are going to substitute in this equation y double prime, 10y prime, okay, 25y equal to the 14 e to the negative 5x. Substitute here. Y double prime, this is Y double prime. It's a 2a1 e to the negative 5x minus 20 a1x. Okay, a1x e to the negative 5x plus 25 a1x squared e to the negative 5x. That's y double prime. Plus 10 times y prime. Plus 10 times y prime. This is your y prime. So it's going to be 2a1x e to the negative 5x minus 5a1x squared e to the negative 5x. Okay. Plus 25 yp. Plus 25 yp is a1x squared e to the negative 5x. Okay, everything equal to 14 e to the negative 5x. That's it. You have to simplify. You can divide all of them by e to the negative 5x and then continue. Because you have to simplify these. Combining the like terms and then just keep going, you see. That make it easier. Now get the leftovers. So we have to 2a1 minus 20a1x. Okay. Then we get 25 a1x squared. We multiply the 10 inside. So that give you 20 a1x minus 50 a1x squared plus 25 a1x squared equal to 14. Combine this like term, the write it down as a polynomial. Just take care of it. We check the x squared, you see 25, 25, and the 50. They all disappear. Okay, 25 and 25 would be 50, and the negative 50 would cancel out. Then you have negative 20 a1x, and the positive 20. This would cancel out. So the leftover 2a1 equal to 14. So a1 would be 7. This is the way you know it's happened. So your yp, remember, was a1 x squared, so that gives you 7 x squared e to the negative 5x. Final answer for the general solution, yc plus yp. Okay, so this is the one that you got to be pay attention. Otherwise, if you miss the duplication one, everything to the left would be 0. And the 0 got to 14. Then you have to go back and check it to make sure you get it right. Okay, so this is going to be the term. We have a couple of more. Okay, let's see how much time we have. I give you a break. We come back. I'll do the other one first. If I get time, I'll come back and do one more for you. Yes, okay. You have to take care of those variations of parameter sets. The variations are a little bit different. Okay, so you got 10 minutes. You come back. And just do one.
I think my sister like voucher, there's already there. I'm hoping something.
Yeah.
Wait, I already know the picture.
Yeah.
Just to get out.
Yeah.
Professor, we're gonna plug in our iPads.
Okay.
Our notebooks are about to die. Smaller.
Yes. Yes.
You know how I was asking you about the synthetic division? Okay, I understand like everything, but I'm trying to like, I was thinking about how to word it to you.
Okay.
Like one is this, you know how we use the 6, we come, everything's divisible by like, I completely understand that part, like, that's clicking through. I am just not understanding like like another way it's like attributable for like another problem, let's say, like just totally
You
different
see,
number.
all these problems will be given to you, you would end up with a polynomial. Okay, like the one that we did out.
Mhm.
You see, everything you do, this is the worst scenario, okay? You get this polynomial. The difference is gonna be this number may be different.
The six, or
No, coefficients.
the coefficient will be
Coefficient may be different, but the thing is, you see, you should find four solutions for this one,
because it's two.
because it's
four.
the division function. Okay, four solutions. Four solution means four numbers that satisfy this equation. Okay,
Mhm.
you try to see, maybe I'm going to make it easy for you.
Mhm.
You try to see, you can find the first one. How? You add this coefficient together. The coefficients, you see the coefficient of the first one is 1, maybe 7, maybe 1, and it's 6. If this coefficient happen to be 0, one of the solution is 1.
Oh,
That
so
will help you
so-
to start.
if it equals 0, R
If
is
it's
equal,
equal,
that would mean R is 1.
or is 1. Yeah.
Okay,
Then you get the one that will help you.
yes,
See, you do the synthetic. When you do the synthetic, you go down one unit for the power. So the
Yes.
power is 4. So this
Three.
would be 3 because you have to see this coefficient of the powers of R.
yes,
Okay?
Uh-huh.
Now you get R cubed. Now you come back again. So you don't got one of them. So you don't have to go back to the original one. You focus on this one, the leftover.
okay, so we found, this is not a solution, or is this is,
This is S solution.
but we need 3 more.
You need 3 more.
So we go back and pick that 6 because that's the only thing without the.
Yeah, you
coefficient.
forget about the original one. You work with this one.
Okay, so we pick the 6 because that's,
6 is the coefficient. No, this theorem that we talk about,
yeah,
will tell us the possible numbers. If you find a possible number, those numbers must divide 6.
yeah,
Divisor of the 6. So divisor of the 6 is divisible by, you have to use possible negative number. Possible negative 1, possible negative 2, possible negative 3, possible negative 4.
okay,
There are quite a lot, but you are interested in only 3 of those. So you
correct,
have to find it.
I see,
How am I going to find it? You have to try.
yeah,
You see, since I knew in advance, that
Yeah.
is one of them. So I checked 2 times.
okay,
You see, if you check 6, for example.
we're not gonna
You
get,
are not going to get 0.
yeah,
You see, the one that Muhammad was talking about it. If you won't get the 0, so this will back like. You
yeah,
have to go to the other one. You
okay,
have to find those 3. So we go to, so since I used the 2, so I have the 2. As soon as you find the 2, so the leftover is quadratic.
Mhm.
You can handle this one.
yeah,
You can either factor it or you can use quadratic formula to find all the 4 solutions.
okay. So I picked the 6 when it's
Yeah,
left
whatever number
over.
it is. If it's gonna be 12, for example.
Yeah, it's just the number without the R, basically, like when we need to go,
Replace it. You see, if instead of the 6, you get 8. So the number that you have to try are going to be what? Positive negative 1, positive negative 2, positive negative 4, positive negative 8.
I get that that's it, but like, do I pick just the 6 with like I know I need to,
Any number like 6, you focus on 6 only.
but it's the number without,
Constant. You call this one constant term. You know R, you call it constant term. So you have to focus on the constant term only. Okay? If it's gonna be, for example, 5, you're unlucky. It's gonna be 5, you can only possibly get 1, possibly get 5.
okay,
Okay, but if you have something like 12, good luck.
yeah,
You
okay,
have to check quite a bit, but we need just one of them.
yes, okay,
This is the quickest way to find it, okay? The other way is just using calculator, drop these numbers into the equation to find one of them.
great.
But in that term, also you have to come back and check it with the synthetic method.
Okay.
Okay?
Synthetic and rational root theorem are kind of different, right? Rational root theorem is like,
The rational root theorem is these roots that you find there. Synthetic is the action of the division that you do.
but with rational root, isn't it just like you would get the first
Yeah, you get the
coefficient?
roots. No, you
divided-
get the roots.
Oh, Okay, I went to the tutoring center yesterday and I had a professor kind of like, she mentioned rational root theorem, but I didn't know if she did it.
Oh, no, you don't even find it in that term. Because that equation, that theorem would have some other condition. It's gonna be just a couple, just one shot. See, it's not gonna be quite large. If it's gonna be in the test, the board. You should check this one. And you should be fine.
Okay, well, thank you so
Try.
much. Thank you. I was just like, I honestly have
yeah.
never done synthetic.
Yeah, we can, this type of group is not in your book in this section.
Yeah.
But we need it.
Yeah, I just
So-
have never learned
No,
it.
yeah,
so-
we better tolerate it.
Yeah, no, it's not that bad at all,
Yeah.
but thank you.
Disciplinary, yeah.
Yes.
It's just good.
Yeah.
Yes. That's better.
And then, thank you. And then, sorry.
You say it's so nice, when you see it.
Okay. And then I want to explain to you what I looked at this problem.
Yeah,
Remember how you said the homogeneous one, how it's different?
yeah.
I knew what my problem was. So
You did everything all right.
I did everything
Then you get
except
to
for
the-
this one.
Yeah.
So I divided by u, but instead I multiplied by u on the other side, or I should have had u here, and then I used partial fraction decomposition.
Yeah, when you divide by you put it here.
Right, and then I'll use partial fraction.
Oh.
Instead, I multiplied by u. I don't know. I was a little.
Because the bottom must be, the bottom must be u times one, u plus one.
Yeah, and then I'll use,
If you check the.
A over-
All right.
and then it'll be a times u plus b times one over u. Right?
Yeah, your method, it's not bad. But
Yeah.
you do, every time you do it, you prove our formula.
Right, right.
You see, why not? That formula is there. VZ f of z minus.
Yeah, I'm gonna do that on the next test, on the finals.
Forget it. You don't have to sit on the final.
Oh, really?
This problem, no.
Okay.
Okay, I remember this. I tried to do it.
Do you need my paper?
Yeah, yes. So I'll do it for you next
All
time.
right, thank you.
Okay.
Oh, it's not for Andy.
If we get to that, that one's gonna be, like, do us something, we'd have like a full lecture.
Okay.
One that would be there for like 2 hours. A lot of things, always gonna do it. Like, we, like, never get to properly. Also, you work, it's hard. It was always challenging. Like, I think 3 last straight. It's the hard road. So we just had to get- Not integration, you do the strategic one. Plus. We're the plus, right?
So wild.
At least one professor.
There you are. Remember that. Okay, let's get the other group. Okay, if I get time, I'll come back to a couple of more of this, but we have to go to the other section to make sure we are able to do all of them. So the other question is going to be number 3. This is the one that you are not going to suppose to solve the question. You are going to suppose to give us only the form of the void P. Okay? We identify the void P, you have satisfied. Okay? It's number 3 that give us a chance to, because we cannot give you these combinations to solve the equation. It takes time. So that's why we form the equation in this form. Okay? So number 3, just find a form of the particular solution and leave it. Don't solve it. Okay? So this is going to be number 3. Give you one question, a couple of them, and this quiz and the next test. So this is number 3. Okay, so in number 3, only find. Okay, find a form for the suitable form for a YP. YP of T, of course, you know, if the method, you know, that if the method of undetermined coefficient are used, you know what we are talking about. So we emphasize that do not evaluate the constant. You see, on the test, you will see the same thing. Do not evaluate the constant. Just identify the 4 points. Okay, this is it. So let's check all of them quickly. The first one is y tiers, the third order, minus 2y double prime plus y prime equal to the t cubed plus 2e to the t. Equation is the equation of the third order. You know that you have to solve the YC to find out if there's going to be any duplication. So solve the YC pairs. So find the YC pairs. So the equation is y tiers minus 2y double prime plus y prime equal to the 0. What's the characteristic equation for this one? R cubed minus 2r squared plus 1 r equal to the 0. No, just wait. Okay, this is easy. We can factor it first. Okay, factor of the r. So that give r squared minus 2r plus 1 equal to the 0. So r equal to the 0 is one of the solution. And the other one also is factorable. We're going to factor this one. R minus 1 and r minus 1 or a square. So what we have r equal to the 0 and we have r equal to the 1 repeated solution. Okay, a repeated solution. You don't need those synthetic or anything. You know, just check to see if we can factor it first. Okay, repeated solution. So carefully identify the YC. What's going to be YC? C1 e to the 0. Next. C2 e to the x. Next. We need 3 solutions. C3 x e to the x. Okay, x to the x because it's repeated. So your YC is a constant, C1. C2 e to the x. C3 x e to the x. This is your YC. You needed to check for the duplicated term. Any question? Now YP. What is going to be your R? YP. You know, they use the T, I use the X, you know, you can change it to the X, doesn't matter. Okay, if you like, you know, you can change this one into the T. Sorry about T e to the T. Or you can stay with the X, doesn't matter. No, but you know, you better stay with the
Yeah.
notation. Okay, so what is Rx? R of x is t cubed plus 2e to the t. It's a two parts. The first part is a polynomial, the second part is exponential. So you have to do two. Okay, we can do both of them at the same time. So the yp would be, we check the polynomial first. T cube is a cubic polynomial. So you have to write a cubic polynomial with the undetermined coefficient, which is, give us a cubic polynomial. A1, A2t, A3t cubed. That is going to be a cubic polynomial, okay? Sorry, I missed something. Sorry. That's a 2 and the A4t cubed. So that would be a complete cubic polynomial with a constant. Yes.
Does it matter because it's used on that A1 or the A4?
That's right. Right. That's what. Okay. Now you have to test it. Is there any duplicated case or the duplicated terms for this one?
Yeah.
Check. Constant. Constant. So we have a duplicated case, okay, term. So we have to raise it. T. Okay, so be careful about it. So we write down the polynomial first, then you check to see if there is any similarity. Duplicated term. You have a constant and the constant. So we have to raise it, you multiply by t. When you multiply by t, you get A1t. So there is no constant term. So we're done with the first one. Any question? Next. Second. The coefficient of the second one, exponential one, polynomial, is a constant polynomial. So you have to bring a constant polynomial. You already go up to the 4, so that would be a fifth. A fifth e to the t. Just starting. You check it for duplicated case, duplicated term. You see, a constant times e to the t, a constant times e to the t. So it's duplicated. So you have to multiply by t. Then you check it again. You check it again, you get the te to the t. And you have te to the t here. So you have to raise it again, which means it's going to be t squared. Okay? So you have to make sure that you don't have any duplicated term over here. So we start with the constant e to the t is here. So we multiply by t, then we get t e to the t. We have it here. So we make it into the t squared. So that gives you the yp. You want, you can rewrite it, but you don't have to. So the yp is a1 plus a2t plus a3 t squared plus a4 t cubed times t. Okay, and that would be in the same thing, a fifth t squared e to the t, the final answer. Even if you write the original one, that would be fine. Okay, so that would be the final answer. No, it doesn't matter. Even if you keep it, it's better. Show that you did consider the definition. You don't want to do anything about the inflation. You are interested in the form of the yp. And because, and you know that's why we don't want you to solve it, because if you want to solve this one, okay.
So,
Yeah.
would the form before it be okay too, or would you want us?
Yeah, no, that's fine. That's fine. Okay. That's excellent. That show us that you did the checking and you have the t and the t squared. That because they are not particular. Yes.
And so because we didn't solve for the constant A, we don't know the general solution to y.
You don't have to because you don't have to. It takes time. It's nothing you want.
But if we put it, just in case for redundancy, you wouldn't mark this down for it, right?
I give it a 0. It takes your time. It takes us 25 minutes to do this one.
No, but if we just put like after all this, if we put y equals y, c.
Don't do it. Just don't do it.
I do not solve it for A, but try to do it constant. Invalid, if I were to write it wasn't that, why
I literally think it's like.
Yeah. Very much. Because they are, let's say, the question was, give us the voice quickly. Because it takes time, you know. Okay, let's quickly give you another one. So, you see again, for this type of problems, the reason that we don't want to solve it, because that would enable us to give you higher order. The second order is, the third order. Takes quite a while to do it. That's nice, you already got the idea, so it's going to be happen somewhere you see. Okay, ready for another one? Have to go to the next page because the other one takes more space. Okay, so this is going to be part B of the same question. Part B, the equation is of the fourth order, minus 2y double prime plus y equal to e to the t plus sine t. This is the equation. Again, solve the homogeneous one. This would be interesting. So the homogeneous one is the fourth, okay, minus 2y double prime plus y equal to the 0. What's the characteristic equation for this one?
R to the power 4 minus 2r squared plus 1.
Let's see, plus 1. We try to factor it. Any suggestion?
Quadratic,
Yes,
r squared, minus one, all that squared.
yes, r square minus 1 all square, or r square minus 1 times r square minus 1, okay? Because we have r to the fourth minus 2r squared plus 1. So it's r square minus 1 all squared.
Yeah, like to know how to factor.
Yes, there are 4 methods to factor.
Yeah, I mean, like, example.
No, that's clear. You just look for the perfect squares. You see, you have r to the fourth is a perfect square. 1 is also a perfect square. So you should look for the twice of the first times second, which is in the middle. So it's very standard formula. You see, a square minus 2ab plus b squared. That's what you see. You look for those perfect squares to be safe. Okay, that's it. So what is going to be the solution? Maybe you're going to write it down now. You see that give you r square minus 1 equal to the 0. So that give you r equal to the positive negative 1. But remember, you should have 4 solutions. So what is going to be those 4 solutions?
One.
That's it, a repeated one. Okay, remember? So the solution are going to be 1, if you like, negative 1, negative 1. Remind yourself that both of them are repeated solution. Okay, in this case. So write the YC. YC. Okay, YC for the first one. C1 e to the t, that's first. Let's repeat it. C2 t e to the t. We're done with the r equal to 1. Now r equal to negative 1. C3 e to the negative t is repeated. C4 t e to the negative t. So this is going to be YC. Okay, because we need to have 4 solutions. So the characteristic values are repeated one. So this is the way we write the distribution. Any question? So that's the YC. Bring the R, give us the YP. So what is R? We want to find the YP. Your R is again a combination of 2 functions. R of t is e to the t plus sine t. So you have to write 1 for the e to the t and 1 for the sine of the t. Okay, so there you are. YP equal to e to the t. Coefficient of e to the t is a constant. So it's going to be a constant polynomial. A1 e to the t. Check to see if it's repeated. You see, a constant times e to the t, a constant times e to the t. So we have to upgrade it. If you upgrade it, you have to multiply by t. But when you multiply by t, you get it here again. T e to the t. So you have to raise it. So this would be the first one. Okay? So you have to check this duplicated term. And accordingly, you find the number. So we are done with the first one. Second one. Second one is a constant times sign. You know that. You have to write a combination of sine and a cosine. So it's going to be plus. I use the A1, so it's going to be A2 sine of the t plus A3 cosine of the t. Any duplicated term? No. There is no sine and cosine in YC. So this would be the final answer. Okay? Any question? Yes.
Then you said if we use X instead of E, as long as it's simply grab the whole thing.
Yeah, in that part of the book, they call it.
So at the very beginning, what he wants to be like t is equal to x. So. Or is it just fine?
No, it's fine.
Okay.
You can go with the echo.
Yeah, can we use like,
Yeah, I have to change it next time.
can we just use our own symbol?
No, it's higher order, it's always coming from physics, it should be. That's the one. That depends which book you are going to use. If you use differential equation by Boyce and diploma, they give you T all of that. If you use the Z, it's the X. So you will see how it comes. It doesn't matter. Yes, question. Do you have any question? Coming to the next one.
So we add cosine by the definition.
What's that?
Why do you add cosine to the constant?
You know that. If you place up with the moving function, you said that the figure Q, you have to have the sign and cosine. So if the sign is not sign, if the cosine, sign. Remember when we do the complex solution, both of them are happening. So that's why you have to. Okay, so that's going to be the case. Okay, we have one more. This is part C. Again, this is of the fourth order, and that equation, it would be interesting for you. Okay, and this is it. It's a y fourth order again. And that's going to be tierce. And the y double prime, y prime. And then you have a t squared plus 4, okay, plus t sine t. That's the equation. Okay. So y to the fourth order, then you go down to the third, to the second, to the first. The other side is t squared plus 4 plus t sine t. Okay, so the homogeneous one first. That is the homogeneous minus y double 3s prime 0. What's the characteristic equation for this one? R to the fourth, R to the third, second, and R. You have to solve this equation. What are we going to do first? Factor out the R out. R cubed, R squared, R plus 1. When you get one solution, you may call it R1. So you let the inside to be 0. R cubed minus R squared minus R plus 1. You have to factor this one. How are you going to factor it? Yes, grouping. We have 4 terms, we have to group it. 1, 2, 3, 4. Group them together. The first group factor of the R squared, so that gives R minus 1. So you pull out the negative sign for the other. So you have a common factor, R minus 1 times R squared minus 1 equal to 0. So we're using grouping method. So we get the other solution is R2 is 1. And over here, we get R squared equal to the 1. So that gives you R equal to the positive negative 1. So our 4 solutions are going to be R is equal to R is equal to the 0, 1, 1, and negative 1. So that is going to be the 4 solutions. So we have a repeated one at 1. Okay, so get the YC. YC is equal to the C1 e to the 0, C2 e to the t, right? It's repeated. C3 e to the C3 t e to the t, and the C4 e to the negative t. So that would be your YC in this case. Okay, all the signs are. Yeah, everything is all right. Okay, there you are. So we get a constant term over here, so we have to rewrite it. So the YC is going to be equal to the C1, C2 e to the t plus C3 t e to the t plus C4 e to the negative t. So that would be your YC. Expect to get a complex solution, you didn't get it? Okay, so bring the R of X, R of T, since this is the one, is a combination of two function, okay, polynomials, T squared plus 4, and the polynomial times sine T, okay? Are you done? I go to the next page to identify the YC for you. Okay. So what is going to be your YP? Okay, we want to get the YP, but R of T, R of T is a polynomial, T squared plus 4, plus T sine T. You do the polynomial first, is a quadratic. So your YP would be a complete quadratic. It's like A1 plus A2T plus A3T squared. That's quadratic. You go back to see if any duplicated term. There is one, remember, we get the C1 in the YC. We get e to the 0, we get the constant term, which is C1. So we have to upgrade it. Upgrade it multiplied by T. Now there is no duplicated case. Any question? It's quadratic. It's a T squared plus 4. So I have to give a quadratic expression, polynomial. The quadratic one is starting what? The constant term T or the other way around. T squared, T to the first, and the constant. Okay, no. Yes.
It would be the same regardless of the 4 being there now, right? If the 4 wasn't there, it would.
Yeah. Okay, so that's it. Plus, now the second one, the coefficient is T, is a polynomial or linear polynomial. So we have to write a linear polynomial times sine, linear polynomial times cosine. So it's going to be equal to plus, we go with the 3, so we go with the 4 and the 5 T times sine T. You have to have something similar for the cosine. So it's going to be plus, we go with the 5, so we go with the 6 and the 7. 7T times cosine T. So that gives you a YP for this case. Okay, so either sine and cosine, yes. You see, the first one is what? T squared plus 4. T squared plus 4 is a polynomial of the second degree. So this means you have to produce a polynomial of the second degree with the unknown coefficient. So the unknown coefficient are A1, A2T, A3T, or the other way around. Okay. So if it's going to be cubic, you have to write it complete cubic. Yes.
All of this for T and T.
That's it, yeah.
So the A4 goes to T and then A5.
Yeah, you need coefficient, you need new coefficient. Because T is a linear polynomial of the first degree. You have to write the first degree complement. The first degree complement one is what? A5 plus A4 plus A5. You can call it anything else you like. Let's coefficient. Because the linear one is what? Like nx plus b. That's a linear. Nx plus b. Right, right. Okay, any question? There is no repetition for the second part. So this is how, we are going to give you one question, a couple of these. Just put them together, make sure that those duplication, yeah.
Isn't the H4 and the H6, where's it multiplied by?
No. Repetition is the original. Not when you write it down, you go back and say.
Yes, well, no, I thought in the YC there was a constant.
You wrote a constant term, that this is not the constant. term.
Oh, it's multiplied by.
See, you multiply by some. Okay, we get sign, the cosine, we can think about it. That's it. Okay, any question? So when you write it down, double check it. Double check to see, make sure that everything is right. Okay, so this is the method of the undetermined coefficient. Now, let's go to the other method that we have. Let's get time to do it. Method of variation of the parameter. That's going to be the one. It's number 5, 4 and the 5. I'll go do the 5 first. You see, remember when we do it? We want to solve each equation by the variation of the parameter. You know, this equation again are all linear. Okay, so what you have to do, you have to find the y term. We arrange it so that all the coefficients are constant for the time being. After you flip, of course, you're going to see the one that the coefficients are not with. That's what you flip, they're all constant. So what you have to do, you have to do the y term. To find the yc would be c1, y1, c2, y2. And in order to find the yp, remember, you are going to change it to the what? u1, y1 plus u2, y2, and then those do that here. Okay, so make sure you have the correct formula to do it, and it takes a little bit more time to do this one rather than the other one. So method of variation of the parameter. Even one or two of these because it takes time. So we go to the number 5. We want to solve each equation. The method, you have no other choice, but this is it. They give you the method by variation of the parameter. Just to remind you in a minute, the formulas. Let's do the first part, and I'll give you the formula. Okay, the first one is a y double prime plus 4y equal to the tan of the 2x. You see, since the tan of the 2x, you cannot do this one by the other method. And determinant of coefficient. Because you can do only those if you get a sign and put them. Yes. Anyway. Okay. Now solve the homogeneous one first. Okay. Homogeneous one. Solution. Carefully solve it. It's not going to be a difficult one, but make sure you get it right. Okay, characteristic equation, r squared plus 4 equals to the 0. You put the 4 to the other side, -4, call it 4i squared, get your r, positive -2i. So we have complex solution. Pick one of them, 2i, identify alpha and beta. You know that it's going to be like 0 plus 2i. So your alpha would be 0, your beta would be 2. Identify the yc. So your yc would be c1 e to the 0, e to the 0 cosine of the 2x plus c2 e to the 0 sine of the 2x. So basically yc is c1 cosine of the 2x plus c2 sine of the 2x. This is yc. Any question? Now yp. You remember in so we want to find the yp. Variation of the parameter. Variation of parameter is this. Yp equal to, remember, we change the C1 into the U1, it's going to be U1, Y1 plus U2, Y2. No, y1 is cosine of the 2x. y2 is sine of the 2x. u1 and u2 is the one that you have to find it for us. How am I going to find it? This is the formula. u1 is integral of negative y2 r of x over the Wronskian. u2 is integral of y1 r of x over the Wronskian. This is your job. You have to form the Wronskian first. Then you substitute in this formula, and then you come back. You come back, you put it into that formula, u1, y1, u2, y2, that gives you yp, and the final answer will be again yc plus y2. Okay, so work with the Wronskian first. Any question? So make sure you bring the correct formula, okay, when you want to use it. So the Wronskian, so we need this is it. So finding the Wronskian is the cosine of the 2x. You have to differentiate it. y1 prime. We have a cosine negative sign it's of the 2x2, so negative 2 sine of the 2x. Okay, y2. Your y2 is sine of the 2x. y2 prime is going to be 2 cosine of the 2x. Wronskian, W is what? Is y1, y2 prime minus y1 prime, y2. Substitute, simplify. It's going to be equal to that. y1 is cosine of the 2x times y2 prime, 2 cosine of the 2x. Okay, minus y1 prime, negative 2 sine of the 2x times y2 sine of the 2x. Okay, what's going to be the result? 2 cosine squared of the 2x plus 2 sine square of the 2x. You know that you factor out the 2 cosine square, sine square is 1, so that gives you 2. So the Wronskian is equal to 2. Okay, you identify the Rx and you go for the integration. But you got to be careful. When you identify the Rx, make sure that the coefficient of the y double prime is 1. If it's going to be anything else, you have to divide it. The coefficient, when you get the R of x, you make sure the coefficient of y double prime is 1. Because the formula, the way we prove it was, okay, got the monic, we call it the monic polynomial, monic equation. Okay, in this case, you don't have anything to worry about it. Okay, so the R of x, we confirm that we did check it. Okay, we did check this one, and the coefficient is 1. So R of x is going to be like only tangent of the 2x. If it's anything else, you have to divide it. Okay, so that gives you tangent of the 2x. Now we are ready. Form the formula. Okay, y2rx, simplify, integrate it, and come back. Okay, so I'm going to do the u1 here if I can. u1 is equal to integral of, we have the formula, negative y2. What's your y2? y2 is sine of 2x. So it's a minus sine of the 2x times rx. Rx is tangent. Tangent of the 2x, Wronskian is 2, dx. Okay, you have to find this integral. We can change the tan into the sine cosine. We can put out the 1/2, negative 1/2. Integral of, this is going to be the sine of the 2x, and this is going to be the sine of the 2x over cosine of the 2x. Okay. And then try. The top and the bottom would be sine squared, cosine squared. Okay. That take you back to the tangent square. which can be integrated right away, okay? The sine times, I'm sorry, this is, let me just go to the next page. So you multiply the top, it's gonna be equal to the negative half integral r. What's that? That's it, okay? So the top will be what? The top is gonna be sine a square of the 2x. And the bottom one would be cosine of the 2x. Okay? Just double check, make sure you get everything all right. Okay. So we get the tan of the 2x and the R2 was sine of the 2x. Okay, everything is all right. So any suggestion how to find this integral?
I have no idea. I've been trying to do this for the past like 30 minutes.
3 minutes. We can, you can change this to the, okay, you can change the sine square to the 1 minus cosine square. And then
Oh my God.
it can be done.
Yeah.
Okay, so if it's going to be, you see it's a negative half, integral of 1 minus cosine square of the 2x divided by the cosine of the 2x. Now you break it, negative 1/2 integral of 1 over cosine of the 2x minus cosine square of the 2x over the cosine of the 2x. You know that 1 over cosine is a secant. So that gives you secant. Okay, and this one, you simplify it, that gives you the cosine of the 2x. Okay? Secant 2x, yes, secant 2x, yes. So basically, you are going to have a negative 1/2 integral of a secant of the 2x dx, if you like, plus 1/2 integral of a cosine of the 2x dx. You remember integral of a secant? Integral of a secant is no.
ln secant x plus tan x.
That's it. Very good. It's going to be ln of the absolute value of the secant plus tan. But you got to be careful here because this is the secant of the 2x. You need the u prime. Then you have to divide it by 2 to get the u prime. Okay, so this is it. ln of the absolute value of a secant of the 2x plus tangent of the 2x. But you have to divide it by 2 because of the u prime. You see, it's a secant of the 2x. So the u prime would be 2. If you differentiate it, you multiply by 2. If you integrate it, you divide it by 2. Okay, that's the one. And then the next one is going to be derivative integral of the cosine would be just sine. So it's going to be 1/2 sine of the 2x, but you have to divide it by 2 again. Plus the constant, not plus constant c, because we're looking for the particular solution. Okay, so this is going to be u1. So the u1 is negative quarter. Yes, we have one more to do. It takes time, the variation. So it's going to be a quarter of the sine of the 2x. So this is going to be u1. Okay, this one problem you good. There is one with the secant, one with the tangent. You have to check both of them to make sure that you are able to carry that integral. Yes. Sorry? You prime. You see half sine of the 2x, secant of the 2x. Oh, when you differentiate another table, multiply. Okay, so go back and find the u2. That would be similar. What's the question? Be quick.
Did you have this 1/2? This one? Because you split it into 2 integrals? Why did you add this 1/2?
Because you see the outside is negative 1/2, the negative 1/2. Okay. Okay, so let's do the U2 to see what type of integral is going to U2. Remember the formula for the U2 is the integral of y1 r of x over the Wronskian. So what is the y1? Y1 is cosine of the 2x. R of x is tangent of the 2x. Wronskian is 2, and there is a dx here. That's easier because the tan is secant sine over cosine. You simplify the cosine, would be the sine. So it's going to be 1/2. That's the cosine of the 2x times by sine of the 2x over cosine of the 2x. So the cosine and cosine would cancel out. So that give you 1/2 integral of a sine of the 2x dx, which is easy. Integral of the sine would be negative cosine. So that give you negative 1/2. And that would be the cosine of the 2x, but you have to divide it by 2 again because of the u prime. So that give you negative quarter cosine of the 2x. So that would be your u2, negative a quarter cosine of the 2x. Okay, any question? If you are not done, you have to come substitute, simplify to give us the YP4. Okay, so what is going to be the YP? Remember, YP is U1 Y1 plus U2 Y2. To substitute, the Y1 was cosine of 2x.
Yeah.
So that would be cos. I just want to multiply by this. Okay, so it's going to be the cosine of the 2x times it by negative quarter. There's not much to simplify for this one. Secant of the 2x plus the tangent of the 2x, we just repeat it, plus a quarter times sine of the 2x. That's the first part. Plus u2. And that is the u2, negative quarter of the cosine of the 2x times y2. What's y2? It's going to be sine of 2x. Okay? So if you multiply these two, the middle one would cancel out. Okay, if you multiply inside, that give a quarter of the sine of the 2x cosine of the 2x, and you get a negative quarter over here. So this is going to be equal to, you get the cosine of the 2x. Okay, I put it all this together. Sorry, I put it, this is it, negative quarter cosine of the 2x. Okay, times ln of the absolute value of the secant of the 2x plus tangent of the 2x. Okay, everything else will cancel out. Because you get these two together, it's a plus a quarter of a cosine of the 2x, sine of the 2x, and you have a negative quarter cosine of the 2x, sine of the 2x. These two will cancel out. So that is going to be YP. YP is a negative quarter cosine of the 2x, ln of the absolute value of secant of the 2x plus tangent of the 2x. That's the YP. The general solution, of course, y equal to the YC plus YP. We already identified the YC for you. Okay, it's a very popular problem with the tangent. You can try it for yourself again, but you can replace the tangent by secant. So that would be again interesting when you put them together. That integral is going to be easier when you get that with the tangent. You have that part that you have to know. You have to put them together. Okay, so this is going to be one of them. So we have. I can give you one more for you. The second part is not bad. Let's try it. We can do it in 5 minutes. Okay,
Would it be better if you want from one?
okay, okay, I'll leave it. Okay, I post the solution for you for 4 and 5.
Yeah,
Okay, 4 and 5, 4 of them.
yeah.
The rest is it. Okay, so you have to pay attention, you can see variation of parameter. It's tricky, you have to practice. You get a feeling that, you know, when you put those signs and those signs. The famous one is this. Sine, secant, tangent, and the other one will be over there, okay? So, that's it, we are ready for the quiz number 2. You have 6 questions, you have the topic.
Wait, so for this one, why did we want a general solution?
Huh?
Why did we want a general solution for this one?
Because they asked to solve the equation.
Oh, it didn't, I forgot.
No, that's to solve the equation.
Oh. Sorry, that's like
You
a
can just ask for the particular solution, you know, this is solve the equation
Yeah.
by using variation of the problem.
it was a whole page ago.
Okay. Yeah, it would be more fun when you bring those last group of the questions. Okay, that's it. So I will post this notes and I include those. Okay, number 4. Yeah, look at it. Look at this. Yes.
I don't really catch it. You said clarify that the coefficient of y prime is 1.
Y double prime.
Y double.
Y double.
Okay. And then I also.
Because if you don't consider that one, in this equation is not much important,
Oh, okay,
but get used to it.
Yeah.
Because in future, these coefficients are in number 4. If you want
that's
to do
gonna be
number
Y
4,
double
because it's
prime.
Euler equation, you get x squared y that is correct. You can't do it. You have to divide by x squared. Otherwise, the integral is getting complicated.
Right, okay. I'll also send you an email, see if you can send me the, my exam. I took it at the DRC.
What's your name?
Angel,
I did it twice for you.
and I didn't get anything.
I email you.
Well, I got it, but it was just an empty message.
Empty message.
Yeah, I can pull it up right now.
I have it on my server. Yes, let's see what would happen to you. Because originally I didn't have your email. Let's see where it's buzzed right. Then do it again. See, I have it here.
Oh,
Yeah.
You could.
Sorry, one second.
yeah. I did it cross.
And I clicked the link, but it just sends me to my email.
Let's check it on this one. Otherwise, when I get home.